Well, hello everyone. My name is Jeremy Bout. I am the host and the producer of Edge Factor, and some of you, of course, have met the stars of Timid Tigress, and we're going to get into that episode in a few minutes, but I just wanted to acknowledge the fact that I am sad that I'm not in Worcester with you guys today because we got double booked. I'm actually on a film set in North Carolina working on some of the new Steam products that we're going to be releasing into our platform later this year. So I just wanted to take a few minutes to address you. Your stories in your community have been part of my story now, and we have, as a team, been in many places, but I remember with great fondness some of the different partnerships. You know, I think of Jim La Liberté and the group over at Phillips Precision, and just these different stories and how they've lived on, and they've been an inspiration to many people. And that's what Edge Factor is all about, is storytelling. It's about engaging communities, and it's really about talking about what the possibilities are. I'm a big fan of manufacturing because when you make things, a lot of jobs come to life and a lot of people find their passion. And so I want to get into, that journey for a young girl. What did Nicole's journey look like? And let's look at that TV show. And by the way, this TV show has played in many places. Arizona, it was on the air there for, I think it played about 5 different times. I know that we've had it on air in a few other communities. We've got NBC wanting to play it in a few communities again. So this story lives on. Your community's in the spotlight in many different places, and certainly this Timid Tigress has been an inspiration to many. Let's get into that episode. After graduating out of middle school, Nicole started looking into which high school to attend. Like most kids her age, Nicole had no idea what she would be good at, and so the search began on what she should study for her career.
For a while, I wanted to be a chemist because I liked going in the fridge and mixing things together. I think that branched off into the culinary thing, and so I like doing food and cooking and just mixing stuff together. I remember all the different looks I got when I was like, hey, try this. And the standard look like, what's wrong with it or what did you do with it? It somehow was introduced to me options after middle school that I can go to Auburn High or I can go to Bay Path. And I didn't want to get stuck going in one direction. So because Bay Path has so many different options of shops to go through, I kind of went that direction.
Our exploratory program starts freshman year. We get to choose 9 different programs that they'll spend one weekend. And after their 9 cycles, they have the opportunity to pick what shop they think they want to stay in.
My very first day at Bay Path was in graphic arts. And I still remember the same shirt I wore because they take pictures of you and you put it on a little notepad and then you do this with it and they put you on a pretend cover of a magazine and they do lots of Photoshop stuff. So that was my very first day and I was like, oh, this is cool. But I did that with all of my shops when I went through it because I was just so open-minded about, I'm just jumping into high school. I don't really know what I want to do. So I'm, oh, this is cool. And then the next shop, oh, that's cool too.
She came to our school wanting culinary, which is a great trade within itself, but it wasn't for her.
I told you to watch him, Nikki. Look at they're burning. You gotta be more careful around here. You're gonna burn my bake shop down. Oh, it won't go out. We'll put it out on the rack. It's far gone. I think maybe you better go down to machine technology. Mr. Austin, he's right here. He's a great teacher. I think you're gonna get along great with him. You're gonna learn a lot. If you can't take the heat in here, you gotta get out of the kitchen. Look at my rolls. You're on fire. It's gonna work out perfect if we don't want you here. Bye-bye. Good luck.
I think she did more damage than she did good.
Look at my rolls. They're destroyed. They're burning.
Cooking definitely wasn't for her. Right out of high school, I worked as a machinist in a restoration shop. We restored British cars, high-end Rolls-Royce, Bentleys, Jaguars, that kind of thing. And my job was to manufacture parts for an automobile that didn't exist. If it was missing a door handle, if it was missing a bushing or whatever, I had to make it from scratch. I couldn't afford a fancy car like that, so I bought my first truck from the town and restored it back to original Vietnam era. And that turned into another and another and another, from half-tracks to armored cars to bicycles. I never served in the military, but it's my way of saying thanks to the vets. I do a lot of parades and shows with them. It just blossomed from there.
Equipped with his personal experiences, practical knowledge, and technical skills, Tate Ostagi is an incredibly talented manufacturing instructor. He inspires his students by revealing the impact that manufacturing has on the man-made products we use every day.
Nicole and I met day one for exploratory, timid young lady, loves her cats. She was there to talk about her cats. No, we're here to talk about machine shop. But she had a little interest, she had a little glow in her eyes that she was really interested in what we were doing. Kind of showed her around the shop, showed her some of the neat things that we do.
You have to walk past all this equipment and you're just like, whoa, what goes on in here?
So one of the things we need to know is where we're going to start.
It was a little overwhelming at first, but I think the more I saw it, the more I got into it.
Within the first 3 days, they have to come up with a design of a keychain that they want to make. Most kids put, mom or dad or their brother's name or their soccer number. Nicole's is a little more advanced than that. I think it had a picture of her cat, and I think it had some other verbiage of something, and kind of out of the box thinking that she always had.
When Mr. O talks about what manufacturing is and what machining is, he picks up anything, anything around you, and there's manufacturing involved in this. There's manufacturing involved in everything around you, and it's just that kind of realization hits you yeah, it doesn't just appear there. Someone has to put the effort in and actually make it, and a lot of that happens in machine shop. So even if I don't know what I want to do, I'm sure I could find something in manufacturing. There's so many different directions I could go. And he said that over and over again, which was yeah, I can do whatever I want. So it was just a giant open door.
Actually, take a CNC lathe, we can program it to make each individual piece. She decided she wanted to get involved with the robotics team. So we kind of put her on a design team to allow her to come up with some pretty cool concepts.
We pretty much supply the body for the robot, which is all the armor plates, the mounting for the tires, the skeleton, if you will, for the robot. And once you start making all your pieces and you start to see it coming together, it's yeah, now this looks like a robot. That's cool. It's the whole design process, really. You start with the design and then you build your components, and then it just looks like a pile of metal and it's just sitting there. But once you start putting bolts in, you're drilling holes and getting things put together, it's this is a robot now. This is a functioning robot.
We were able to take her to Florida a couple times to compete on behalf of our program.
You get 3 minutes in the ring, and every minute we switched off drivers. So I've never driven the robot before, but for 1 minute solid, I drove the robot. And I'm I don't really know what I'm doing, but that's fine. I'm just gonna go around and it's gonna be fine. So each team switched off drivers, which was it was fun. It was fun, it was different. After going through competition and hearing different people speak about robotics, it also helped me open my eyes as to how much I was actually doing. When you're there, you're just so into it, you don't realize all the stuff that goes into it. Wow, I learned all that cool stuff just making robots.
Coming up, with 4 years of high school wrapping up, for better or for worse, Nicole thinks about what next steps might be as she looks to launch her career.
Sometimes change wasn't good for Nicole.
My indecisiveness is overwhelming sometimes.
Nicole needs to make a decision. Will she enter the workforce or pursue a higher education? Feeding off the energy of Tate Ostagi, her teacher at Baypath, Nicole Smith has decided that there are great opportunities in manufacturing for her. Even though none of her family have pursued a post-secondary degree in the past, Nicole decides to break the mold as she explores options at local community colleges.
They tell you not to do this in high school. They're don't pick your college because of how much money it costs. But that is exactly what I did, because that's what I felt like I had to do. Because I was the one who went the other direction in school. All my other friends went to the other schools, and it was just, I was kind of on my own, and I'm just kind of trying to push through trying to figure out what I want to do.
With her high school graduation behind her, Nicole looked to the future. Moving down a different path than many of her friends, Nicole enrolled at Quinsigamond Community College.
I definitely could not pick whichever school I wanted to go to, and part of the reason I chose Quinsig is because it was affordable.
I believe it was Kathy Wrench called from Quinsig, and she was in a panic, and she just said the professor just up and quit. No explanation, just quit.
Steve Phillips is the owner of Phillips Precision, but he also sits on the board of Quinsigamond Community College. When Steve got the call that they needed an instructor for the manufacturing courses, he accepted the challenge to take on the position, but with one condition: the class had to be run in his shop.
Put up or shut up, that's one of my mottos, so I figured, well, I'll see what I can do to help them out. I wanted to have the class at my shop because every machine in the shop I'm comfortable with. I can just go in fluently from one machine to the other, and Mastercam and the CMM, and I think they were exposed to a lot more than they would have been in a school setting.
Being in a shop environment helps a lot when you're trying to learn about future careers, and so it kind of connects the dots. It's a lot more relaxing if you're in the shop environment and I'm actually doing something instead of just looking at a screen, taking my notes.
We're going to do feeds and speeds, which we've kind of already talked about. In the beginning of the class, we did the sit down, you know, all the formulas and all the classroom part of it, the GD and T, speeds and feed formulas, and that's, you know, something you have to do, but then we were able to apply it out in the shop, and that was the fun part.
It was definitely different because it wasn't standard procedure, teacher, whiteboard, okay, this is how you do this is your homework.
What I wanted you to do is to go past it.
He talked to me about the two students that he had in the class. One in particular was Nikki. He can pick out a person who may have the aptitude for it pretty quickly.
The CMM is a very, very delicate instrument, and I'm very, very particular about who gets to run it. I didn't feel at all uncomfortable with letting her do it. She was very, very cautious, very careful, and had an easy touch on the machine. She was pretty good, and I was hoping that maybe she'd be interested in going to school specifically for that and hopefully teach me how to run it better.
We've been sort of thinking about hiring an inspector or someone who could handle some of the more technical parts of the work that we do, and you know, he recognized that in Nikki. There are a lot of soft skills that we look for, not necessarily just the aptitude for the trade and the interest in the trade, but the soft skills that come with it.
We were looking for somebody that was honest, dependable, trustworthy. You'd have a pretty good head on your shoulders, and you have to think on, you know, like an engineer. It's changed tremendously since I've started in this business.
Graduating from Quinsigamond, Nicole turned her 2-year degree into a 4-year bachelor's in industrial technology at Fitchburg State University. Seeing her skills in action, Steve knew she would make a great addition to their team, even if it was in a part-time capacity.
I remember it was a Thursday that I was thinking, yeah, I should write an email or something to ask if I can work there, because I kind of really like it there. I'd been thinking about it in the beginning of the week, and then that Thursday he had asked me if I wanted to stay there and work there, and I'm like, oh, well, that works out, yeah. Yeah, sure.
Having Nicole on the team was giving Phillips Precision the ability to take on new work. For Steve, this meant he could compete in new markets.
We have a fairly new customer, Draco Racing. He was looking for a local shop that he could deal with. So he popped in and we started making parts for him. He was a little apprehensive because he wasn't sure the quality was going to be there. He was used to buying nice parts, and these were going into some really expensive cars. We're trying to make a really high quality part for a reasonable price. That's kind of why we're still in business. Nikki's in charge of that quality, and she makes sure that everything fits right and looks nice, and she's working with all men, and sometimes she can be tested. We had one particular gentleman that took that to a different level. He was making parts that were not to our standards. Nikki brought the parts into me and said, well, these parts don't look very good. They weren't to print. He argued with her, they were good enough. This company was very, very particular about the look. I mean, everything was plus or minus 10. They were like not an accurate part, but they had to be pretty.
He just decided that the work that he did was just going to be it. He didn't want to have to answer to any inspector, especially Nikki.
Finally, he ended up throwing the parts on the finish bench and bypassed her. She was furious. She had never really had this kind of a confrontation with anybody before.
Coming up, things escalate as Nicole gets a taste of real life. Red tape is slapped on the parts, and somebody is going home. Nicole Smith had just begun to step into her role as a quality control inspector at Phillips Precision. Working on projects for the racing community meant that Nicole needed to guarantee that the parts were made right. But not everyone appreciated her attention to detail.
He ended up throwing the parts on the finish bench and bypassed her, and she was furious.
She really took the bull by the horns and really knew she needed to push back on him.
Put a red tag on those parts and put it on his desk. He's either going to quit or he's going to fix them. He quit.
He rolled his box out the door before we got to work that day, and all done. That was the end of that.
I think it worked out pretty well.
Nicole knew that if they were going to make their mark in a competitive industry like the motorsports world, there was no room for failure when it comes to quality.
I assured him that they're going to be good, and if you don't like them, send them back. I'll throw them away, you know. That wasn't the case. He was very pleased with them. He said that the quality was better than they were accustomed to.
It is exciting to go to a race and see what performance the cars need in order to function at the level that they do. So it's really cool that hey, look, I make the part that goes on that car. Part of the reason that car functions is me.
Nikki's in charge of that quality, and she makes sure that everything fits right and looks nice. And
making sure the quality is there so that way it does continue to function properly.
It makes me really proud to know that our team put those parts together, and they're coming back for more parts because they're happy with the quality and the service that we've provided.
Nikki helps me with a lot of the processing the jobs through the shop and documenting them so that the next time we pick them up, if it's a repeat job, she's very detail oriented and she will make sure that she goes through all of that and documents it for us. Our quality manual needs to be revised and she is on board with that. She fits in really well in the team, evens the odds a little bit. Some of the paperwork that I get to share now, I didn't have anyone to share with before.
With her skill set, she's going to be right on the cutting edge of anything, any new technology that we embrace. She's going to be right there learning it and teaching us how to use it. She may not realize it, but with all the new technology coming down the road, she's going to be a very, very busy girl.
Being in the field now, it's completely changed my perspective of how I look at things. Assemblies come in, the whole print, and we're making every component of that assembly. And you see how all those things, like piece by piece, just like with the robots, when you're putting robots together piece by piece, it all comes together and you realize this is a functioning part that goes into some bigger assembly.
Nicole is exceeding even her own expectations, and while painful at times, going against the grain is already paying in dividends. With advanced technology, software, and CNC machines all around her, Nicole has just begun to scratch the surface of where her career will take her. And whether it's the racing industry or other markets, Nicole's attention to detail is already making its mark. By breaking out of her shell, realizing her potential, and focusing on success, Nicole is unlocking her road to greatness. For Nicole Smith, this is her launch point. Well, it is always fun to watch how a story just can take on a life of its own, and it can be used in so many different ways. And I think that's one of the things that we want to educate you on today. Brian asked me, can you explain what EDU Factor is? Because you could start with a great story like Timid Tigress or one of the over 40 shows that we have now produced. But that's not going to be enough. I look back at my high school days and the idea that math, quite honestly, not very relevant to me until I got into manufacturing. I pulled those books off the shelf and I got back into it. And so we use our stories to start really engaging people with why they're learning what they're learning. You think about careers, for so many people, they just don't understand how to get into a career that's valuable to them. And so our platform, EDU Factor, takes the story and it starts to make learning relevant. We do that in a few different ways. And I want to play a little video here that will explain how we do this in the career side of things.
Welcome to EDU Factor. Today we're going to explore some of the tools available to show students careers and pathways available in manufacturing. You'll notice the zones are how we organize the resources in EDU Factor, and those will appear along the top of the screen as you move through the system. We like to say it all starts with a great story. So if you find a story, you can find supporting resources to help explore those career pathways for students. Let's take a deeper dive into the career exploration zone. Here we have opportunities to share stories of LaunchPoint. These are full episodes that have interactive exercises to reach students in and out of the classroom. It's a great way to engage students with really taking a deeper dive into some of our stories of our characters and the pathways they've chosen. We also have rapid fire career activities. Rapid fires are videos that are less than 6 minutes where we meet a character and find out more about what that pathway looked like for them. Let's take a look here with Cassie. You can click the option to create a new activity. It'll create an automatic code for you. You'll see that this code will expire in 60 minutes. You have a shareable URL as well. So if I go ahead and click on Launch Activity, the student will enter their information and start to explore Cassie's story. So we include video and media and questions for the students to complete for their homework assignment as well. If you love one of the resources, simply go ahead and click this button and it will be saved to My Favorites. You can tag anything as your favorite and easily find it when you're back in the system. Happy exploring!
Well, just this week, we're in North Carolina filming a whole pile of new career things. We're talking actually specifically on mechatronics. So if you're an EDU Factor member, stay tuned. There's a lot of new stuff coming out from a careers perspective. But we want to get into technology as well. I don't know if any of you had the chance to go through Brian Cummings' program and actually see some of the machines in action. Certainly if you've watched Timid Tigress now, you would have heard and seen many different types of tools and the names of these things being thrown around. But what are those things? Well, we love to break things down, and there's this thing that we call Geek Out. And I want to get into a little explanation now on how you could take a story like Timid Tigress and let's start to geek out on some of the technology in that episode.
Today we're going to start in Watch Films. This is where you can view any of our LaunchPoint or Edge Factor show episodes. Today we're going to use Gnarly Metal Part 1. When you go into the episode, you'll see the opportunity to play the trailer, play the episode, or you can view additional resources. Here we have moments where you can meet the individual characters, find out more about their career pathway, but we also have opportunities to explore the technology the students have seen used in the episode. Things like, how is CAD used? How is CAM used? We also have opportunities for the students to go ahead and do things like explore technology. In the Explore Technology zone, we have Geek Outs. Geek Outs are a way that we can take a really complex subject for students, simplify it in less than 6 minutes. We have things like what is G-code, milling versus turning. So some great opportunities that you can go ahead and add these to your favorites to access them later. You'll also notice that we have technology lesson plans. These include short videos and handouts for students as a way to again highlight the technology they've seen in the episode. Don't forget that you can tag anything to your favorites so you can go back and find them at a later time. Have a great time exploring.
Well, of course, in the middle of all this technology, there are great ways to be thinking about STEM. As a STEM teacher, you get this. You look all around. STEM comes alive in almost everything. So we want to use our stories to start to make STEM, or should we say maybe STEAM? I'm a big proponent of the art side of this. So let us explain a little bit where we're at today.
Here we have all of our different resources and activities categorized under science, technology, engineering, or math. Our goal is to highlight moments in manufacturing where STEM's happening, and it happens every day. Let's take a look at the rotational motion and momentum. This is a great activity that's available for 11th through 12th graders, but there's no reason you can't use the activity with younger students. Our goal with rotational motion and momentum is what is the force and body mass that it takes to flip a bike. So you can go ahead and you can download the activity illustration and handout. You can also play the attached activity video for students as well. In 15 minutes, you can take this moment and make math relevant for students. Love any of the resources and just click on this button. It will automatically add it to your favorites. Then next time you log in, you just go ahead and click on the favorites button and your favorite STEM resources are right at your fingertips.
Well, for many of you, you may be saying, look, I don't want more curriculum. Well, that's the thing that we're trying to do with Edge Factor. We want to give you tools to help you make your existing curriculum relevant. You know, when you're introducing concepts like trig, or you're talking about linear equations and all these different things, we want you to be able to just grab a go-to teachable moment. And we're doing this in so many different ways. And so this week alone, we're filming 2 STEAM tours. We're in factories, we're meeting people who craft all sorts of amazing different products, and we're showing how STEM or STEAM comes alive in these factories. We're doing this in career pathways as well as these factory tours, and we're going to introduce you right now to a video that we shot at Haas Automation. If you've spent any time at Brian's program or other H-Tech schools, you would have seen these machines, these CNC machines. Well, I'll tell you what, STEM comes alive in that factory. Here's a factory tour from Haas Automation in Oxnard, California. Well, I'm not sure there's anything quite as exhilarating as hanging out with an inventor. Someone who took an idea from their head, connected it with their hands, and brought their idea to life. You know, for them, maybe the whole thing started with a napkin. They started sketching out an idea for something because there was a need. Maybe it went into Autodesk Inventor or Google SketchUp and they 3D printed it. But you know things are getting serious when the chips start to fly. And if you've been to an H-Tech, of course, you've probably seen CNC machines. There's an inventor named Gene Haas, and his invention has dramatically changed many people's lives. And I'm gonna give you an inside look at what it takes to make his invention, a CNC machine, come to life.
In 1980 high school reunion, Gene asked me if I would help him build some equipment for his shop. The quote was, "Hey Kurt, you know about electronics and computers and stuff, would you help me build something for my machine shop?"
What Gene did is he took those manual indexers and he machined them, and he built in gear and worm drives, a stepper motor, and a control. And that device then automated the process with the use of a switch that was triggered when you pull the handle on the mill. You'd go down and drill, you'd bring to the up position, it would rotate automatically. So it would speed it up. It was all about automation.
By 1984, we were looking at other people's machine tools, and in 1987 decided to start designing and building our own machine tools, the kind of things we see all around us in this room.
CNC machine, the VF1 was developed in 1988. We took it to IMTS. We showed it at a number of shows. It caught on instantly. We bought 86 acres of land. We built our first building, a 200,000 square foot facility, and expanded from there. Before we knew it, we're at 1 million square feet, a factory, producing a peak of about 15,000 machines per year. 2 years ago, we hit our peak of $1 billion in revenues, and we just continue to grow from there.
This company has a lot of soul. People care about what they do. They're involved. They can help make decisions and make things constantly better.
I can make this machine, make a part exactly to the specs I want, do it over and over again very precisely because we put the right kind of technology and engineering and math and science and computer programming skills into a machine tool that can do this thing very repeatably, very fast, very accurately. And for us, the math is a tool to know how to use this machine with these materials and these tools to make a part that has a certain shape and size.
Engineering is very important to us. We realize that unless you design and develop the right product the first time around, you might as well not bring it to market.
Our machines are designed to build everyday components, from your wristwatch all the way up to the engine block in a car, to the remote control that you press the button. We create products to build these components, and that's what Haas is about.
It's a non-traditional type of work environment for a designer. I think you have to love science and you have to be into an engineering mindset or a creative mindset that likes to problem solve.
We develop not only the machines, but also we build and program the controls ourselves. They're easy to service, they're not overly complex, they're priced right as a result. If you can do all that, you can bring all that together, you can build really the right products. So we have to have a lot of knowledge, a lot of capabilities in-house as far as engineering goes. And that's an area where our CEO, Gene Haas, really shines. He specifically focuses on engineering. He spends most of his time in the engineering area, driving engineering.
He will look at something, some engineer, a new guy put it together and says, no, that's nothing like I wanted. You didn't consider, and he'll introduce a whole different way of looking at it, a whole different way of presenting information or accomplishing some engineering task.
He has a very, very good team of electrical engineers, mechanical engineers, manufacturing engineers, a whole variety of people that come together to make that happen.
What keeps me coming to work every day is knowing that I create something that is functional, that people are using. Everyday people are using that, which I think is beautiful.
I love what I'm doing. A lot of the times I use math. It's a great experience. I'm learning a lot from other people as well.
Once you've designed the product, now you have to build it. We have a significant machining operation here at Haas Automation. We machine almost all of the machine parts that end up in our product. That goes for the castings that weigh sometimes up to 30 or 40,000 pounds. The precision parts that end up in our machines, the spindles, for example, the tool changers, the gears that go into our gearboxes.
We spend up to $500 million a year in terms of components and services and equipment. We bring in £6 million a month of castings, for example. We're bringing in sheet metal, we're bringing in bar stock, and then there's all the components as well. 15,000 different components, predominantly from the US, but we also buy from other countries as well. We'll get ball screws, for example, from Germany. We'll get servo motors from Japan. It's truly a global supply chain. In terms of math, we're working with numbers and dollars. We've got to calculate costs, we've got to analyze savings, so it's a key part of the job. So math and technology is always there.
We use math in the sense that we have to check geometry on the machines. We have to get the right angles. When the machine is cutting, we cannot have it be off. Otherwise, we won't have a consistent cut.
In high school, I wasn't so interested in math, but my senior year when I started working in a machine shop, I suddenly realized how much math you use, and I'm like, no, I should have paid more attention.
We operate some of the most high precision gear making machines here in the world. We have very, very strict controls over gears, and that's an effort to build very, very quiet, very precise gears for our machines.
I always knew that I liked working with my hands, and I also liked working with my mind, which in manufacturing that's perfect because you're constantly running around, you're doing all kinds of stuff, making all kinds of things, and I'm using math all the time. It's been a great career to get into, and since the time I started in this industry to now, I've definitely been able to enhance my skills and also make a very good living.
It's about how you got from point A to point B to point C. And really it starts with the machine. And so you're going to have some general awareness and love for just technology in general, building things, electrical components, design, because it all plays a role.
I interact with a lot of the machine shop, I interact with assembly, and I interact with a lot of the engineers. I really enjoy the fact that I'm diversified in many aspects of the company.
We can assemble a finished machine in a week or less, and with minimal failures. Because we've pre-tested and pre-certified all these assemblies that are going into the product, it speeds the whole process and ensures that you have fewer failures. And in many cases, they're going into containers and shipping to ports all around the world. We're shipping about close to 1,000 machines a month. Half of those end up in North America, and half of those go offshore.
Every day is a challenge, and every day brings those rewards when you deliver.
We have millions of dollars in inventories around the globe. And that's just so that when something happens, when something fails, we can get that replacement part to a customer immediately. Every aspect of sales, service, the installation, the customer relationship is very, very important to us. We established the Haas Factory Outlet Network, HFO, and with the HFO comes a number of quality standards. And that ensures that our customers can always expect a consistent experience from buying through delivery, through servicing of their product.
The best part of my job is when I complete a project or resolve something for someone and the outcome is far better than they expected.
My job is to support all of the HFOs throughout the world, and the major job of that is answering questions. And the key to that is answering questions before people ask them. STEM fits into my job on a daily basis because I'm responsible for selling a product that's very technically oriented.
This place in many ways is the epitome of STEM coming alive.
It's just nonstop, and that's what I like about it. It's very fast-paced and always learning something new.
In a manufacturing company, you can do sales, you can do accounting, you can do a hands-on job, you can be the company nurse. I mean, almost any job that you might get, there's probably a place for you in various manufacturing companies.
I never in my wildest dream would think I would end up here, but I'm here and I'm embracing every minute of it.
The best part of my day actually is working with my teammates. I love working with them day to day. It actually is great coming into work. I'm actually excited to be here.
Science, technology, engineering, math, those are all skills that are used here. We see them every day. We see them in our employees. We see them in our customers. Our products are core to STEM-based industries.
While to some this may seem like chaos, you know what? It's more like an orchestra. All of the different components coming together, not to an end, but to a beginning. A machine that is going to go into someone else's hands and it's going to bring dreams to life. And that, to me, is the legacy of Haas. Well, as we look at building our STEAM tools, we of course do that through the lens, through the stories that we're telling. And in 2017, we're going to have 4 major stories coming out. And I'm going to show you a couple of clips. One of them is on a story about a group of students who are building stuff, many different items. This one particular that we're going to feature is a locker that will make its way to the International Space Station with a NASA Hunch program.
It is a dream that unites humanity. A longing to reach outside this place called Earth and explore what lies beyond this planet. You are here today because you chose to believe you could make something that would reach beyond the clutches of gravity. I congratulate you on a job well done.
Well, the man talking in that video landed the space shuttle at the International Space Station on 3 different occasions as the commander of the shuttle. This story is all about students using their head and their hands. They're actually building something that will go to space. You talk about inspirational. You talk about math coming alive. You talk about engineering and art all merging. And to me, that is the kind of story that we just love to watch students just engage with. Well, in 2017, we're also working on another story. And I want to leave you guys with this thought, because if you look around, you look at everything that we touch. You know, a lot of people, they go and they buy stuff, and they don't even think about where it came from. They don't even realize that it's manufactured often in places behind closed doors all over the place. And of course, I'm sitting with a drum kit behind me. And this was made out of a maple tree that was harvested up in northern Michigan. And in this new documentary that we're telling, we're working with the most famous of drum makers, John Good from DW Drums, and we track this entire story, and it is amazing. We're working with some of the biggest rock stars out there, from you know, some of the online, the YouTube drummers, to we've got, you know, J-Lo's percussionists, we've got Jason Mraz's percussionists, we've got guys and girls of all different ages. You know, in fact, I co-wrote with Neil Peart, the drummer from Rush, on this film, and in this little segment, I'm going to introduce you to this very dramatic scene where the water is rising in a storm 1,500 years ago. That was a catastrophic event where trees fell in the river, and they eventually got hauled out about 5-10 years ago, and out of that log that had been sitting there for 1,500 years, they crafted the very, very famous R40 drum kit. Now, why am I telling you all this? Because inside of stories like this, there are incredible ways to engage with students and parents. You can bridge gaps in your community, and you can use stories like this to get people fired up about why learning really is important. And so I hope you enjoy the rest of your conference. I hope you enjoy your day, and most of all, I really hope you enjoyed this little teaser for the film called Masters of Resonance. Again, I'm Jeremy Bout, and I'm just so thankful to spend a few minutes with you guys.